Alright, let's take a look at another kind of synthesis problem. This is where we're given products of aldol or aldol type reactions and Claisen reactions. Now what we can look at here, first of all, with the aldol is that we know that the pattern to form an aldol goes as follows. We take the C double bond O of one and join it to the carbon that has the alpha hydrogens on another molecule of aldehyde or ketone, and we end up getting a C double bond C joining where the C double bond O was and the alpha hydrogens from the other molecule. So a fairly simple pattern. Stands to reason though that we can take this and reverse it by splitting apart the C double bond and giving the C double bond O to one and the two alpha hydrogens to the other. And we always do this in this way. We always put the C double bond O on the compound that doesn't have the C double bond O, and we put the alpha hydrogens on the one that needs alpha hydrogens. So you can see that that's fairly clear as to how that pattern would follow if we were trying to get the things that were going to be used to form that particular compound. With the Claisen process, what we're doing is we are going to, if we're forming a Claisen product, we're joining the alpha carbon of one molecule to the C double bond O of the other and losing methanol. So we're losing OMe and H off each part of the compound. So to reverse the process, what we would do is we would break the bond between the alpha carbon and the beta carbon, that's the beta to the C double bond O from the ester group, and then we would put the H on the part that had the ester and the OMe on the part that didn't have the ester. That would give us our two compounds that were going to be used to form our Claisen product. Now it's important that we break this particular bond here, the bond between the ketone and the alpha carbon to the ester. So that's very important, otherwise we won't get the right compounds back. Alright, so let's see how we would handle that given this example. So if we split this CC double bond, we'll end up getting these two compounds. Knowing that this will get the C double bond O and this part will get the alpha hydrogens. And as I said earlier, the part that doesn't have the C double bond O gets the C double bond O. So we know those are the two reagents that are going to be used. The next step is to figure out what kind of aldol it actually is. As it turns out, this is a Novnagel condensation, and I know that because one of the substrates of the Novnagel contains two carbonyl groups, and we know that the Novnagel goes the way it does because of the extra high acidity of the hydrogens between the two C double bond O groupings. Now, you might be wondering, well, how would I know that it's a Novnagel? Well, what will probably happen if you go back and take a look at your test, if you look at question 1, every question 1 I've ever had has an example of an aldol and an example of a Novnagel condensation somewhere in there. And you'll be able to go back to your question 1 on your test and you'll be able to figure out which one is the aldol and which one is the Novnagel. So the aldol will be the one that reacts two compounds that have just one C double bond O each, whereas the Novnagel will have one compound that has a C double bond O and another one that has two C double bond O's. And what you'll be able to do is simply copy the conditions of the Novnagel reaction and use those conditions on your synthesis problem as well. Now, since ours is a Novnagel on our reaction, I know that I will just be able to copy the same conditions of the test question, the question 1 question, which was NaOMe, methanol, and second step H+. Now obviously, had this been a straight aldol reaction, what I would have done is just gone ahead and used NaOH and H2O as my reagents in that instance. So as you can see, it's just a matter of identifying the reaction and then using the appropriate set of conditions by copying them off the same reaction in question 1. With the Claisen, we're not so concerned with that because we really only have two kinds of Claisen reactions, the cross Claisen and the regular Claisen, and both of those happen to use the same conditions, so it's not such a big deal. Alright, so that would be the answer to the first part, because joining these together under these conditions will give that product. Alright, so this one, again, what we're going to do is we're going to cut this particular bond, and it's the bond between the alpha and beta carbons to the ester grouping. So I'll do that, and I know that this portion will get the OET, and I know this portion will end up getting the hydrogen. So you can see this is going to be just a standard type Claisen reaction, not a cross Claisen. Not that it would really matter, because the conditions won't change. Alright, so there you go, that's how you would do it. And you know that the OET will go on the part that doesn't have the OET group, and the hydrogen will go on the alpha carbon to the ester group. Now as for the conditions, we know that the conditions for a Claisen will always be a base, but most importantly the base and its solvent will match the ester that we've got in the first step. So this is an OET. If it was a methyl, for example, then this would be Me, this would be Me, this would be Me, and this would be Me as well. So everything would match whatever ester we have in the very first compound that we're given that we have to make. And then the second step will be the addition of H+. So again, the most important thing to remember here is to make sure that everything matches whatever ester group you happen to be given here.